Hi everyone! In this video, we will be introducing a research that AP Chemistry students worked on towards the end of the year. The research consists of explaining how different kinds of Elmer's glue affect the elasticity of bouncy balls that we have created throughout the research. The creation of the bouncy balls took around 3 days. In the first day, we created all of the bouncy balls, but we indeed ended up with a mistake, so we had to redo everything again. The mistake was that we never thought that the bouncy balls will harden the next day, so we had to adjust everything and redo the process in a way that it would be done in the same day with more accurate results. Here's the explained process. We started out by splitting the research into three. Ari as well as Alex will be working on doing bouncy balls using Elmer's white glue, glow in the dark, glitter, as well as changing color under UV light bouncy ball. Omar will be working on the formation of a different bouncy ball using rubber, latex, and vinegar. All of the members of the lab group were using their phones to light up the recipients so that they can have a better view of the measurements and accomplish perfect measurement. The formation of the color-changing bouncy ball was done with the initial measurement of 30 milliliter of the glue in a recipient. As you can see, Ori is in turn using her phone for exact measurements, and she is working on the formation of the glow-in-the-dark bouncy ball with the initial measurement of 30 milliliter of the glue in the recipient as well. Now, Ori has started working on the glitter bouncy ball with the initial measurement of the same 30 milliliter glue in a different recipient. Now, Omar in turn started with the formation of the liquid latex bouncy ball. The procedure of this one is different. It involves an initial measurement of 15 milliliter of the rubber latex in the recipient. After having all of the different kinds of glue put in different recipients, the lab members working on the Elmer's glue bouncy balls are going to start measuring out 1 to 3 grams of borax depending on how much is needed until the glue gets a form similar to that of a bouncy ball. In most of the cases, it took around 3 grams of borax to cross-link with the glue. In the meantime, Omar has measured out 15 milliliter of water to add on top of the rubber latex. Just a reminder that the rubber latex procedure is different from that of the glue ones. After adding the water, Omar has moved on to measuring 50 milliliter of vinegar that will also be added up on top of the previously mixed rubber and water mixture. Now Ori and Alex are going to start adding water to their glue-based bouncy ball to end the procedure and have them done. The water plays a role in the texture of the ball but doesn't have much effect on the cross-linking process. While mixing non-stop, Ari is going to put the vinegar on top of the rubber latex mixture that Omar has worked on. The following step includes non-stop mixing until the bouncy ball is formed. Ari now has the glue mixture in her hand, working on making it into a ball shape. It's important to have all of the bouncy balls with the same shape and volume for the research. Now Alex in turn is working on making the mixture into a ball shape. Both of the glitter and the color changing bouncy balls are now ready for testing. It has been realized that the rubber latex mixture isn't getting activated and still occupies a liquid form. Omar will try to add more of the vinegar, trying to make the procedure work. After several trials, the rubber latex didn't work. Omar is going to try a different approach by changing the volumes of the water and vinegar and try to hypothesize which is responsible for cross-linking with the rubber. On the other hand, Alex is going to do the same procedure that was performed on the color changing glue but now using glow in the dark glue. The procedure involves the measurement of the glue as well as borax and water, followed by the precise mixing and the formation of a round shaped ball. Now that the glow in the dark glue is done, Ari is going to do the same exact procedure of the bouncy ball but using white Elmer's glue. Our first hypothesis was that the white glue will bounce the highest as it will be the most elastic ball. We thought that since white glue has the most polyvinyl alcohol in it, this means that cross-linking with borax will be the highest, making it bounce higher. After having all of the bouncy balls ready except for the rubber one, and after having several trials done on the performance of the rubber bouncy ball, the group has decided to remove it from the research proposal and move on without it. Alex is working on setting up a yellow sheet that has measurements on. The bouncy balls will be dropped from the same height and the measurements will be recorded throughout 3 trials. The same procedure was done 3 times for every bouncy ball and the heights were recorded. And the chemistry calculations research started after. This is our first research proposal that also includes all of the procedures, but as explained, the rubber latex got eventually removed and additional glue, like glow in the dark and changing color glue, were included in the research as well for more results and better comparison. This was our final research poster that goes into deep explanation of chemistry and biochem as well. It turned out that our hypothesis was rejected and that the white glue ball bounced actually the lowest. We were able to explain such thing throughout the poster. It turned out that the more the borax or borate ion, the higher the cross-linking, thus the more elasticity. We thought that the more OH or glue, the more elasticity. So it was a matter of borax to glue ratio that played the role of elasticity on the white glue ball. Glow in the dark as well as changing color bouncy balls bounced the highest. But the explanation was different. Phosphors are used in glow in the dark materials, zinc sulfide and strontium aluminate being the most common. It has been identified that both zinc sulfide as well as strontium aluminate play a role in elasticity, thus explaining the higher bouncing. Throughout the poster, there was also a lot of nanomedicine approach that were included with the explanation of the research. It is very interesting to read about.